Okay, so today we're going to start looking at 7.1, Introduction to Hypothesis Testing. So hypothesis test, we will study an important technique in inferential statistics called hypothesis testing. A hypothesis test is a process that uses sample statistics to test a claim about the population parameter. We use this a little bit during our last unit when we were looking at confidence intervals and testing a claim and seeing, does this percentage or mean fall within the range of the confidence interval? So here we're going to look at it a little bit more detailed. Researchers use hypothesis testing to make informed decisions. When we look at hypothesis tests, the first thing we're always going to do is we're going to state our hypothesis. A statement about a population parameter is called a statistical hypothesis. To test a population parameter, you should carefully state a pair of hypotheses, one that represents the claim and the other its complement. So stating the statement and the reverse of it. When one of these hypotheses is false, it means that the other one must be true. Either hypothesis, the null hypothesis, or the alternative hypothesis may represent the original claim. So getting a definition of both of these hypotheses, the first one is a null hypothesis. Which we abbreviate as capital H with a subscript of 0, is a statistical hypothesis that contains a statement of equality. Okay, so this would be such as less than or equal to, greater than or equal to, or equal. Okay. And then our second hypothesis is called the alternative hypothesis. We're going to use capital H, lowercase a as the subscript, is the complement of the null hypothesis, H sub 0. Okay. And it is a statement that must be true if the null hypothesis is false. Okay. And it contains a statement of strict inequality. Okay, so that would be your less than, your greater than, or you're not equal to. Okay, so our null hypothesis is read as H sub 0 or H naught, and our alternative hypothesis, H sub A. Okay. So when we write the null and alternative hypothesis, we translate the claim that's going to be written in verbally, or sorry, not written verbally, will be written in your description or your problem. And we're going to translate it into a mathematical statement. Okay. And then you're going to determine, okay, is that equality or inequality? So is that our null or our alternative hypothesis? And then write its complement. So that way we can write both the null and the alternative. Okay, when we do this, we're going to always assume that mu equals k for your mean. Okay. So this example here shows you the 3 different ways you can see your hypotheses written. Okay. Our mu will also potentially change to be our population parameter P, and then our k values are always going to be numerical. Okay. So the following table shows the relationship between possible verbal statements and the parameter mu and the corresponding null and alternative hypotheses. Similar statements can be made to test other population parameters, and the other ones that we're going to see or can see are p, standard deviation sigma, or our population variance sigma squared. Now, the last two we're not going to look at. We're only going to worry about that population parameter p. Okay, so I went ahead and gave you a table from your book that gives you different verbal statements and how you would write those as mathematical statements. What we're going to look at now is this example. Write the claim as a mathematical sentence, state the null alternative hypotheses, and identify which represents the claim. So, a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So we have proportion, which means that we're looking at P, and we're looking at least, which is greater than or equal to. And then our 61%, we're going to change to be 0.61. So the claim, if we write that as a mathematical statement, becomes P is greater than or equal to 0.61. So now we're going to write our hypotheses, null hypothesis and alternative hypothesis. And we want to know which of these is our claim. So we have that greater than or equal to. Since this is equality, that means it's our null hypothesis. So P is greater than or equal to 0.61. And I recommend that you also always write next to it that that's your claim. And that will help us at the end when we're making our inferences. Okay. So if P is greater than or equal to 0.61, the complement of that, or the opposite, would be P is less than 0.61. And that's your hypothesis. You're done. Okay. So if you look at the second example, a car dealership announces that the mean time for an oil change is less than 15 minutes. So our claim is always about the population. So here our mean is going to be mu. So mu is less than 15 minutes. So it's less than 15. Okay, so now we need to look at it. Does that represent a null hypothesis of equality or an alternative hypothesis of inequality? Since there's no equal sign, that tells us that it's going to be our alternative hypothesis. Mu is less than 15, which is our claim. And then state your null hypothesis. So it's still going to be mu and 15, and the complement of less than is greater than or equal to. Okay. And our third one, a company advertises that the mean life of its furnaces is more than 18 years. Okay, so mean means we're still looking at mu, and then more than 18. So our claim is going to be mu is greater than 18. And that's going to be our null or our alternative hypothesis. Since there's no equality, it is going to be our alternative hypothesis, which means that our null hypothesis will be mu is less than or equal to 18. So this is always going to be the first step of every problem we do this unit, is determine what is our claim and what is our hypothesis. All right, the next thing we're going to look at is statistical test and p-value. So a p-value is one method we can use to test a claim. So after we state the null and alternative hypothesis and specify our level of significance, which we'll talk about later, this is going to be alpha. The next step in the hypothesis test is to obtain a random sample from the population and calculate the sample statistics, such as the mean and the standard deviation. The statistics that is compared with the parameter in the null hypothesis is called, sorry, I skipped a spot. Well, hold on a second. Okay, so after stating the null and alternative hypotheses and specify the level of significance, which is our alpha, that symbol I wrote above, level of significance, the next step in a hypothesis test is to obtain a random sample from the population and calculate the sample statistics such as the mean, the standard deviation. The statistics that is compared with the parameter in the null hypothesis is called the test statistic. Okay, the type of test used and the sampling distributions are based on the test statistic. So the ones we're going to look at from this table is going to be our mu, our population mean, and our test statistic is still our sample mean. And we're going to talk about using a z-test and a t-test. We're also going to look at our population parameter for the proportion, but we are not going to worry about the variance this year. Okay. So one way to decide whether to reject the null hypothesis is to determine the probability of obtaining the standardized test statistics in less than the level of significance. So definition of this says that if the null hypothesis is true, a p-value or a probability value of a hypothesis test is the probability of obtaining a sample statistic where the value is extreme or more extreme than the one determined from the sample data. So the p-value of a hypothesis test depends on the nature of the test. So there's 3 types of tests, and you have pictures down here below. Our first one is left-tailed. We have right-tailed. And we have two-tailed. Okay, the type of the test depends on the location of the region of the sampling distribution that favors a rejection of the null hypothesis. This is always going to be determined by the alternative hypothesis. What's nice about this is our alternative hypothesis is that strict inequality. So it's a less than, greater than, or not equal to. So for left-tailed test, this is going to be when we're less than. It's pointing to the left. Right-tailed is going to be when it's greater than. It's pointing to the right. And two-tailed is going to be when we're looking at not equal. Okay, so we're looking at the two sides then. So what we're going to look at now is in 2 examples where we're going to state the claim, the hypotheses, and then we're going to determine what type of test it is. Okay. So a consumer analysis reports that the mean life of a certain type of automobile battery is not 74 months. So our claim is that the mean, mu, is not equal to 74. So we need to say, is this our null hypothesis or our alternative hypothesis? Because it's not equal to, means it's going to be our alternative. So mu does not equal 74, which is our claim. So now we want to write the complement of not equal, which is going to be equal to 74. And now we want to look, based off the alternative hypothesis, are we going to be left-tailed, right-tailed, or two-tailed? Not equal means we're two-tailed. And if we want to sketch this graph, you're drawing your standard normal curve. And we're going to shade the two tails. Okay. Now, this is going to be half of our p-value. And this is half of our p-value. We'll talk about what that p-value is in 7.2. Okay. Second one, a realtor publicizes that the proportion of homeowners who feel their house is too small for their family is more than 24%. So proportion means we're looking at P. So our claim is going to be P is more than 24%. So greater than 0.24. So our null hypothesis and our alternative hypothesis. So greater than 0.24, is that going to be the null or the alternative hypothesis? Because it's strict inequality, it's our alternative hypothesis. And the complement of P is greater than 0.24 is P is less than or equal to 0.24. Because of that greater than symbol, that means that we are left-tailed, two-tailed, or right-tailed. Because it's pointing to the right, it is right-tailed. And then if we sketch our graph and our standard normal curve, we're going to shade the area to the right. And that shaded area is going to represent our p-value. Because there's only one, we don't need to divide it by 2. All right, so almost done. Okay, when we are making decisions and interpreting that decision, the first thing we're going to look at is the 2 decisions we can make. So to conclude a hypothesis test, you make a decision and then we interpret. The only 2 possible outcomes we can have is that we're going to reject the null hypothesis, or we're going to fail to reject. Okay, you're never going to be able to support the null hypothesis. You're only going to be able to reject or fail to reject. So then we can make decisions based on a p-value, which we're going to talk more in depth about next class. With that, if our p-value is less than or equal to alpha, our level of significance, then we're going to reject the null hypothesis. And if p is greater than alpha, then you're going to fail to reject. Okay. So failing to reject the null hypothesis does not mean you've accepted the null hypothesis as true, which is what I mentioned earlier. It simply means there's not enough evidence to reject that null hypothesis. If you want to support a claim, you're going to want to make sure that claim is written in your alternative hypothesis because of the way that we write our inferences and interpret our decision. Okay, this box is going to be your best friend when it comes to looking at our interpretations. I highly recommend that you circle it, star it, write it on your hand, something. Like it's going to be your best friend. You're going to need it when you're doing your homework and when you're determining your final answers. Okay. So we're going to actually save this example to go over in class at the start of 7-2.